So this lecture is going to talk about voltage division, and I'm going to give a quick overview of how to do it and then give a quick example. So first thing we want to look at is that when you have multiple resistors in a single loop, this is being the single loop, the source voltage will be divided according to KVL, which is Kirchhoff's voltage law, also known as loop or mesh analysis. Now remember how to do that is you're going to set everything equal to 0 when you're going in a loop. For example, if you're starting here and you're going into a loop, you want to set all the voltages across each one of these to 0. The sum of all these equal to 0. So if you're starting with 0 equals, now if you're starting here and we're going in a circle, you can choose whichever way you want. Starting here, we're going to go across this voltage source. So we have a voltage gain because we're going from here to here, so negative to positive, so that's a voltage gain, so it's going to be plus Vs. Then looking at this first resistor, R1, resistors absorb energy. So whenever you're drawing your current loop, you want to automatically put a plus, then minus. So this way, going plus to minus. And you always want to do it according to which direction it's flowing. So if we went this way, you'd have a plus here and a minus here. Since we're going this way, we have a plus on the left and a minus on the right, and we're going to do that for each one. Plus, and minus. And so the voltage across this resistor is going to equal V1. The voltage across this resistor is going to equal V2. And the voltage across this resistor is going to equal V3. Now this is just notation. We haven't really done any calculations yet. So starting here, going in our loop, we've got a voltage gain of Vs, which we did here. Now following this loop, we hit this resistor, and then we have a voltage drop. So we're going from plus to this negative, so that's a voltage drop. So that's minus V1. Following the loop, we have another voltage drop, minus V2. Coming down here, we have another voltage drop, again because these are resistors and they absorb energy, it's minus V3. So this is our KVL equation, but let's break it down a little further. Now you know that V equals IR. That's one of your big equations that you should have memorized. Now we're going to break down each one of these. So usually Vs is given, or we're trying to find it, but you can just bring that one down. Now let's break down this V1, which is here. And we're going to label this current just I, just for notation purposes. You can label it whatever you want. So this first V1 we have, we're going to bring it down, but we're going to break it up a little bit. So V1, say we put it here, equals your I, which we have here, times R. So here we're going to have R1. So the voltage drop from here to here is going to be the current times this resistor R1. Again, bring down this negative sign. This V2, again, is going to equal this I, because there's only this one current loop, times your R2. So the voltage across this resistor is going to be I, this current, times R2, equals this V2 right here. And again, doing it for this resistor down here, this voltage drop. So that is going to equal I times R3. So this is the equation. We got to break this a little further into things that we know. Okay? next step you want to do is you want to rearrange this just a little bit. It's a little sloppy. So here we go, we're going to do this also equals to 0. After we rearrange this, it's going to look something like this. So we're going to move V onto the other side, get rid of these negatives. Vs equals I times R1 plus R2 plus R3. And you can have as many resistors in a series as you want. So if it's R1 through R17, you'd have R1, R2, R3, R4, so on and so forth in this parentheses here. So when you're trying to find, for example, let's say you're trying to find this I, if you rearrange this again, you can find the current that's going around in this circuit. So if you rearrange this, your I is going to equal your voltage source over top of all your resistors, or the equivalent of all the resistors. So that's going to be one of your big equations. But let's break it down a little further. So the voltage across the nth resistor. So we're going to make an equation for what the voltage across any of these resistors are. So if you remember, you're going back up to this equation, V equals IR. So if we're trying to find the voltage across the nth resistor, it's going to equal IR. So here you can see that we've already found I. So we're going to plug that in right there. And then we're trying to find it around a specific resistor. So only one resistor, for example, R3. We would put that value there. But for now, we're going to put Rn there. So to make one big equation, we have Vn equals, and we're going to plug this thing, I, which we found earlier, into this equation, which is Vs over R1 plus R2 plus R3 times Rn. So a general equation that you might want to have memorized is that for any voltage across a resistor, you're going to use this equation. So Vn equals your voltage source over top of your the sum of all the resistors. And then I'd like to put TS here, which stands for resistor total, but in series. So that's what that stands for. Again, that's resistor total, so the total amount of resistors, but only that are in series, which these are in series. And then to finish this up, you're going to times by Rn, so one specific resistor. And this is our general equation. So, now we're going to do a quick example, and I'm just going to put this general equation right up here so we can see it. So for this circuit, it looks kind of big, but don't worry, we're going to walk through this. So this question is asking you to first find current I. And remember, we found an equation for current I up here. So automatically, I'm going to write this equation down for I. So remember, you have V equals IR. And if you arrange that, your I is going to equal V over R. So make sure you're able to rearrange that equation to however you want. So first thing we need to do is question number 1, find the current I. First thing we need to do, though, is we need to make this, get these things so that they're not in parallel. Again, voltage division is only for resistors in series. So we need to redraw the circuit according to how we like it. So I'm going to redraw this. We can leave him there, the 3 ohm. We can leave this 1 ohm here. Now we're going to analyze this part right here, because eventually we're going to try and find V of AB, or the voltage across A to B. But this initial step for problem number 1 for finding the current I, we need to find that first before we find VAB. So VAB is the end goal, but we're going to take a preliminary step and find I. So first thing is you need to look at the circuit and start combining your resistors. So here we have a 2 parallel resistors that we're going to combine. So when you have resistors in parallel, the equation for that, to combine them, let's do a colon here. So the R total, or R equivalent, however you want to say it, let's do R equivalent, equals, your R1 times R2 equals R1 plus R2. So that's a quick way to figure out the value when you're combining resistors when you have them in parallel. It's a little quicker equation than 1 over R1 plus 1 over R2 and so on. So this is a little bit quicker to use this one. So we're going to use it on this. So here we're going to have 4 times 4 over top of 4 plus 4. So I'm just going to do this, 4 parallel 4, but remember you can use this equation. I'm just doing this to save time right now. And then we still have this plus minus V of AB, that being A, that being B. Same thing for here, you're going to use this equation. So 5 times 5 over top of 5 plus 5. Again, just a quicker equation. For right now, I'm just going to do 5 parallel 5. And you can apply this equation. So now that we've broken this down so it looks a little better to us, now you can see that it's all the resistors are in series. So to find I, remember we have, let's see, bring this down a little bit. We have this equation right here. So again, I'm going to draw the loop this way and say that this is I, because it's up here. So solving number 1, find current I. We have I equals, now we have the voltage source here, which I forgot to write on here, so that's actually 50 volts. So we're going to write that down here. So I equals your Vs, which here is 50 volts. So we're going to write 50 here. And now we need to sum up all of the resistors in series. So here we have a 3. Going in a circle, we have this 3. Then we have a plus 1. Then going here, we have a plus a 4 parallel to 4. And then down here, we have plus 5 parallel to 5. So that's going to be your I value. And you can plug that into your calculator. And that'll be your I equals whatever that number is in amps. So now we're going to use that number, which I guess I could calculate it. Let's calculate it. So Here's my calculator. And we're going to have, let's find 4 parallel 4 and 5 parallel 5. So 4 parallel 4 is 4 times 4, and that's divided by 4 plus 4. Just like that. So that actually is going to equal 2, right there. And same thing for 5. So 5 times 5 divided by 5 plus 5. So that's going to equal 2.5. There. So plugging this equation into my calculator to find I, we have 50 divided by, make sure you use parentheses, 3 plus 1 plus 2 plus 2.5. Because this number, I'm going to change it to a fraction form, equals 100 over 17. And that's your I value. Now, to find VAB, again, we're going to use this equation, this general equation down here. So you're trying to find VAB, which is going to be your VN, equals your voltage source, which here is our 50 volts, over top of our R total in series, which is here. So that's going to be your 3 plus 1 plus 2 plus 2.5. Now I didn't have to write all this because remember that equals I. Remember we found it right here, which is equals I. I just wanted to show you you don't need to find it separately. You can find it all together here, but I like to break it out. So I broke it out here. So you could have just done VAB is equal to 100 over 17. So your I there. And then times your R. So that's your I value there, which we found here, times your R value. So it wants the voltage across AB. So when you look up here, it's looking for the voltage across this distance, no matter where it is on the parallel circuit. It's not necessarily mean this one or this one. It's across this whole one. So if you, since we made it into parallel, it's still across this area. So your R value there is going to be your 4 parallel 4. So times 4 parallel 4, or we calculated out it by 2, so times 2, like that. So to calculate all that up, our VAB is going to equal 100 divided by 17 times 2. Make that into a decimal. So for this problem, VAB equals 200 over 17 volts. And that's your answer.